There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromide, lithium, beryllium, and barium. Isn't that interesting?
3, 2,
I hope you're all paying attention.
fire.
There's going to be a short quiz later on.
Okay.
There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury and molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radenzine, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Okay, everybody, we're going to do a little example of a redox reaction here. I've got some pool muriatic acid, and I'm going to put it away, and I'm going to get some zinc metal. And this is going to be an example of an oxidation-reduction reaction. Okay, so I've got my acid and I've got some zinc metal. As you can see, the zinc metal. And now I'm going to be very careful and put the zinc metal in. I'm going to put the top on loosely. And you can see a gas escaping, and that gas is hydrogen. Okay? Usually you don't use that high concentration of the hydrochloric acid. You can feel a little warmth. Not real warm, but it's a little warm. Yeah. Okay, now I want to make sure I can let the vapors out. Okay, it's a redox reaction. The zinc is losing electrons to the hydrogen ions. It's getting oxidized, LEO, Leo. Leo the lion goes grr. LEO, loss of electrons, oxidation. Grr, gain of electrons, reduction. That's the way I help my students understand it. Now, the zinc looks as if it's dissolving. It's not dissolving in the sense that it would dissolve in water. It's actually reacting and changing from a solid to an ionic form, zinc ions. And as the zinc gets used up, the reaction will stop. Once the solid zinc gets used up, the reaction will stop. That will cause it's practically gone now, as you can see. Not worth trying at home unless you have some experience with it, trained as a chemist, or a little experience with that. I don't advise using 30% hydrochloric acid. It's very strong, and the reaction is very dramatic that way, but if some of it gets on your skin or in your eyes, you're in big trouble. All right?